Aviation disasters are incredibly rare. Yet whenever they strike, what we witness feels so unreal. Flames, shattered metal, and devastation that seems utterly impossible for anyone to walk away from. But what makes them so deadly? Why does an aircraft ignite so fast? And why are survival rates so brutally low when disaster hits? To understand the truth, we have to go deep inside the aircraft, into its structure, its materials, and the violent forces tearing through it in those final catastrophic moments. Let's start with the biggest factor, which is the element that powers every aircraft: the fuel. A modern commercial jet carries an enormous amount of it, not just a few liters, but tens of thousands. A Boeing 737, for instance, carries around 20,000 liters of jet fuel. Larger jets like the Boeing 737 or Airbus A350 can carry more than 100,000 liters of fuel. This fuel sits mostly inside the wings. It is compact, efficient, but vulnerable in a high-impact crash. Jet fuel is essentially refined kerosene, a highly energetic liquid designed to burn steadily inside engines. But during a crash, the situation changes completely. When an airplane hits the ground or an obstacle at high speed, the wings tear open and the fuel tanks rupture. Here's the crucial part. The fuel doesn't simply spill out like water. It is violently thrown into the air, breaking apart into a mist of tiny droplets. Fuel in mist form is extremely explosive. As a result, when it encounters sparks from torn metal, broken electrical wires, friction, or engine heat, it ignites instantly. This is why many crashes turn into massive fireballs within seconds. The fire itself is only part of the story. What burns inside the cabin is just as deadly. This is because airplanes are built using lightweight materials such as plastics, insulation, composite panels, carpeting, foams, and wiring. Although these materials are designed to be strong and fire-resistant, everything changes in a violent crash. The heat from burning fuel can reach temperatures above 1,000 degrees C, hot enough to melt aluminum. Cabin materials can catch fire, release toxic gases, and produce thick black smoke that spreads faster than most people can move. In fact, in many accidents, passengers die not from the flames, but from smoke inhalation long before fire reaches them. Let's also talk about something people often overlook: the forces involved in a crash. When a plane is about to crash, it's rarely falling from the sky in a flat, controlled way. Most accidents happen during takeoff or landing, when aircraft are close to the ground and still moving at extremely high speeds. A typical commercial aircraft lands at around 250 kilometers per hour. That's faster than most race cars. At that speed, even a small loss of control can create forces far beyond what the human body can survive. The impact can cause the fuselage, the long tube where passengers sit, to break apart. Seats can be torn from the floor, overhead compartments can collapse, and passengers may be thrown with enormous force into the seat in front of them or into the walls of the cabin. In many cases, the structure collapses before anyone even has a chance to react, and once fire begins, time becomes the biggest enemy. Aviation safety rules require that every passenger must be able to escape a burning airplane within 90 seconds, even if half the exits are blocked. Why 90 seconds? This is because studies show that after 1.5 minutes, the heat, flames, and toxic smoke inside the cabin reach unsurvivable levels. That's why flight attendants always insist on keeping the aisle clear, knowing your exit row and leaving your luggage behind. Every second counts. Every second lost puts lives at risk. It is also important to understand that not every crash becomes a giant fireball. Some accidents, like smooth water ditchings or runway overshoot, don't rupture the fuel tanks. In these cases, survival rates can be surprisingly high. In fact, the majority of airplane accidents are survivable. But when fuel, impact, and sparks combine in the wrong way, the results can be catastrophic. So when you see those dramatic images of burning wreckage on the news, remember, it's not just a crash. It's physics, chemistry, and extreme energy happening all at once. A violent impact that tears metal apart, a mist of fuel that ignites without mercy, materials inside the cabin feeding the flames, and a race against time where seconds determine who survives. Yet despite all of this, air travel remains the safest form of long-distance transportation. Every accident teaches engineers something new. every tragedy leads to better materials, stronger designs, and smarter safety systems. Today's airplanes are tougher, safer, and more fire-resistant than ever before. But understanding why crashes are so deadly reminds us just how powerful and complex these machines are, and just how important every safety step is, from the pre-flight briefing to the seatbelt sign. In the end, airplanes don't burst into flames because they are weak. They burn because they carry immense energy, operate at intense speeds, and are engineered for efficiency, right up until something goes catastrophically wrong. And that is why airplane crashes are so difficult to survive.